Alright, so this is the homework from page 82 through 83, numbers 1 through 15, I believe. Okay, so let's do that right now. So let me just, alright, so here we go, and we are ready to go. So number 1, describe in writing or with pictures how 7/3 compares to 1/3. Okay, obviously, I think it's easier if you drew pictures. Okay, so let's do 7/3 in pictures. Is my magic pen. Right, 7/3 means something that was cut into thirds. Here's my chocolate bar, cut into thirds, and that's 1/3. That's another 1/3, and that's another 1/3. So that's 1/3, 2/3, 3/3. Obviously not enough. That's another 1/3. This is another 1/3, and this one. So that's 1, 2, 3, 4, 5, 6 pieces of 1/3. And guess what? I need one more. I'm going to shade 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, and I got one more right here, 7/3. So that's what 7/3 looks like. 7 pieces of 1/3. Let's try 2 and 1/3. 2 and 1/3. So again, something I cut into 3 pieces. 1, 2, 3. And I don't know why there's a lag here, but alright, so here we have 2 full chocolate bars. One complete chocolate bar. It was cut into 3. I ate all 3 pieces. Another chocolate bar cut into 3. I ate all 3 pieces, meaning I ate 2 chocolate bars. And the last chocolate bar here was cut into 3 pieces, and I took 1. You can notice that it's the same. So 7/3 and 2 1/3 is exactly the same. How are they related? They are equal to each other. So you can change, one is an improper fraction, the other one is a mixed number, and you can tell that they are equal to each other. So if you were to change 7/3 to a mixed number, 3 goes into 7 2 times, 1 left over, and denominator of 3. And if you were to change the mixed number 2 and 1/3, you would multiply the 3 and 2. You would multiply the 3 and 2 right here. Okay, 3 times 2 is 6, plus 1 is 7, and 7 1/3. So just both sides equal to each other. So you could have proven this 2 ways, either changing them, okay, um, or using pictures. Okay, so 7/3 and 2 1/3 have equal value. Question 2. Oh no. On a number line from 0 to -10, where is that located? -13. So let's draw a number line. Very crooked one again. 0. From 0 to -10. So we're going left. -1, -2, -3, 4, 5, 6, 7, 8, 9, and 10. So -1. This is -10. And where is what? -13/3 located. So I'm not too fond of improper fractions, so I like to change this to a mixed number. So 3 goes into 13 4 times, 1 left over, and 3. So that's -4 1/3. So let's do that process on the side. So, sorry, this is a 3. 3 goes into 13 4 times. 3 times 4 is 12, and 1 left over. So here's my whole number, and the remainder goes on top of the numerator, 1/3. So -13/3 is the same thing as -4 1/3. Much easier to put this on the number line. Okay, so that's -1, -2, -3, -4, and from -4 I'm taking 1/3. So from the next block here, okay, let me cut that into 3 parts. I would stop right here. So that's -4 and 1/3. Okay. 3. Copy the number line below. Locate and label marks representing all that. Okay, so these are all positive numbers, and what you're given is that this is 1, and that this is 1.5. Okay. Your first number is 2 1/4. So you know what? Let me continue this number line. Make that 2. Okay, this is not to scale, by the way. Okay. 4, and let's go all the way to 5. Alright, sorry. From 1 to 1.5. 1 to 2. Ooh, 1 to 2 is pretty big, so this is not to scale. You know what? Forget it. Let me just draw this again. Okay, so here we go again. Try to make it better. So that's 0. That's 1. That's 2. That's 3. That's 4, and that's 5. Okay, so that's 1.5. That's 2.5. That's 3.5. That's 4.5. So our first number is 2 1/4. So 2 1/4. So here I am at 0. I'm going to go 1, 2, and 1/4 of my next one. So if this is 2.5, 1/4 should be right here. Let's call that A. I'll write A on this side here. Okay. 1 9/10. Let's call that B. So I'm going to take one step and 9/10. So from 1 to 2, if I were to cut that in 10 little pieces, from 1 to 2, I would go 1, 2, 3, 4, 5, 6, 7, 8, 9. So it would be right around here, very close to 2. And I'll put a B over here. And then 15/4. It's an improper again, so I'm going to change that to a mix. 4 goes into 15, I don't know, about 3 times. 12, you have 3 left over, and 3/4. So for 15/4, 3 3/4, it's 1 step, 2 steps, 3 and 3/4. So this next section over here, imagine if we cut it into 4 pieces. Well, it's cut in 2 right now. So if I cut each half into 2 again, now I have 4. So this is 3, 3 and 1/4, 3 and 2/4, and 3 and 3/4 would be right here. And that's called that C. Okay. Number 4. Copy the number line below. Locate and label a point representing each fraction described. Okay, so here's a number line. And they give you that this is 1, and this is 1.5. Okay. Always put arrows at the end of your number line. Tell me that, that the number line goes on forever and ever on both sides. So A, a fraction close to but greater than 1. So something that is close to, what? Something that's close to but greater than 1. So something that's around here, a little bit greater than 1. Well, let's make it right here. All right, so that's the half. Let's make another one. This is 2. Okay, so I'm picking this guy right here as a number that's close to 1 but greater. Close to but greater than 1. So it has to be greater than 1. So that's a half right here. If I cut something that's a half into half of a half is a quarter. So that would be 1 and 1/4. Okay, that would be my example. A fraction close to but less than -1. So here's 1, here's 0, here's -1. Okay. Careful, extremely careful here. It says less than -1. Something that's less than -1 is not, if you choose something that's on this side, that is greater than -1. Okay, remember, if you're on the right side, anything, a location on the right side will always be greater than the location on the left side on a number line. Okay, so with this question, if you pick a fraction that is right here on this side, that's going to be greater than -1. Okay? Alright, so let me erase that. You want something on this side. So that would be -1, and I don't know, let's make that -1 1/4 just to use our example on that side. So it's a little bit more, -1 1/4, and that is less than -1. If you would compare this spot with this spot, who's on the right side? -1 is. So -1 is greater than the other number. Okay. C, a fraction close to but greater than a half, 1.5. So here's 1, here's 1.5. So you want something that's close to this number but greater, which means it has to be on this side right here. Okay. So why don't we cut this in half again and call that 1 3/4. Sort of close. Probably can get closer, but that's close enough. And then D, a fraction close to but less than -1.5. So let me change colors because that might be okay. So here is okay, -1.5. So we want something that's close to this blue line here, but less. To be less, remember, since they said less, it has to be on this side, not on the right side of the blue line, but on the left side. Anything on the left side will be less. So let's use that example that we use on the other side and pick a fraction, that one. Something that's between -1.5 and -2. So that would be, I would call that, make an error, -1 3/4. Okay, so you have to be very careful here with the word less. Okay, where are we? 5. Right, each mixed number is an improper fraction. Okay, that's easy enough. 1 second. Okay, so this one is easy. You want to change all these to an improper. So first one is 1 2/3. To change to an improper, I guess some of you guys want to do this. It helps. Okay. Make an arrow like this, and you want to make an arrow like that. So the first thing you want to do is multiply 3 times 1, which is 3, and add the product to 2. You get 5/3. So 1 2/3 is the same thing as 5/3. 6 3/4. Okay. 4 times 6 is 24, plus 3 is 27. -9 7/9. So 9 times 9 is 81, plus 7 is 88/9. And please add a negative sign. -4 2/7. Okay, 4 times 7 is 28, plus 2 is 30. It's 30/7, and again, that is a negative. Okay. Question 9, 22/4. So now we're going backwards. We're changing the improper to a mix. 4 goes into 22 5 times. You have a leftover 2 or 4. You can simplify the fraction and leave it at 5.5. Okay. 10/6. That can be 1 4/6. And if you want to simplify, you can make that 1 to 2/3. Okay. -17/5. 5 goes to 17 3 times. You have 2 left over. 5, and that's a negative. Please make sure you put the negative sign. And -36/8. 8 goes into 36. I have 4 times, and you have 4 left over 8. That's a negative. You can simplify the fraction. You leave -4, and 4/8 simplifies to a half. Okay, very easy. 13. What numbers have an absolute value of 2.5? Okay. Okay, so think of numbers that have an absolute value of 2.5, meaning what numbers out there are 2.5 spaces, steps, or 2.5 whatever away from 0. Alright, so with this one, I'm going to draw a number line. So here's 0. So who's 2.5? Well, on the right side, this number right here is 2.5 spaces away from 0. So you can say that the absolute value of 2.5. And there's somebody else who's exactly 2.5 spaces from 0. He's on the negative side. -2.5 is also 2.5 spaces away from 0. So you can also write that -2.5 is 2 spaces and a half away from 0. So two numbers have the an absolute value of 2.5. A positive 2.5 and a negative 2.5. Okay. 14. What are some numbers that have an absolute value greater than 2.5? Okay. Number line. Right, that's 0, and let's just make this 2.5. So, how many numbers you know that if you take the absolute value of, it's going to be greater than 2.5? Well, let's take a number over here. 10. Is positive 10, is the absolute value of positive 10 greater? Wait, sorry. What numbers? Okay, I have an absolute value. Alright, so 10, the absolute value of 10 is 10, so 10 has an absolute value that is greater than 2.5, which is greater than 2.5. Right, that's obvious. 10 is, you have, if you're at 10, obviously you have to take more steps to go back to 0 than if you were standing here. Another number, I don't know, 12. 12, the absolute value of 12 is 12, which means 12 is greater than 2.5. So these numbers are further away from 0. So vice versa, on the other side, negative 10. Took the absolute value of negative 10 is 10. So negative 10 is also further away than 2.5. So there are a ton of numbers that are much further away than 2.5 is. Okay? And those are just 3 examples. 15. A football team has 4 chances with the ball to gain 10 yards and keep trying to make a touchdown. A team gains 7 yards. So here's a football field, okay? Alright, touchdown over here. So, okay, well, maybe not. So let's try it again. Football field, 2 sides. Okay, one team is going this way, the other one is going this way. Okay, so if you ever watch football, one team has to, okay, that team has to go all the way that way to score, and this team has to go all the way this way to all the way down the other side to score. Touchdown. Alright, so let me change colors. Let's say, so team is here. Let's say they start right here. Okay, and they went 7. Okay, and then they lost 2. They lost, if they're at 7, they lose 2. They're now at 5. Then they gain 4. So if they're at 5 and they gain 4, they are now at 9. And then they lost 1, which means they're at 8. So after 4 plays, they are here. They gain 8 yards, or they're at the 8-yard line. How many total yards did the team move? Okay, 8 yards. Did they gain enough to keep the ball? No, they did not, because after 4 plays, they had to be at a minimum of 10 yards. So they had to cross this line right here, which they didn't cross. Okay, they went 7, they lost 2, which made them go to 5. Then they gained 4, which made them came to 9. From 9, they had to gain 1 more, but instead they went backwards 1. So they stopped at the 8. Did they gain the 10 necessary to keep the ball? No, they did not. Okay, so this was a homework video for pages 82 and 83, number 1 through 15. Again, if you have questions, please email me. Okay, you can use the email and schedule it, or you can use the email on our class website. There's a contact form us link on the website. Okay, and that's it for this one. Okay.